Scientists have found that sunlight can bake plastic waste into a soup of tens of thousands of organic molecules. Can you imagine that? Leave a cheap plastic bag in the sun long enough and it'll eventually crumble into a powdery mess, its petrochemical fragments destined to be blown far and wide by the elements. Now, these microplastic fragments, considered a major ecological hazard, all on their own might not even be the worst thing to come out of this disintegration. A study by researchers from Woods Hole Oceanographic Institute finds sunlight is not just capable of breaking plastic down, it can even convert their base polymers and additives into a soup of new chemicals. This process is not exactly slow either, with a variety of plastic bags experimented upon leaching a significant mix of soluble organic carbon compounds after being exposed to sunlight for less than 100 hours. Now, in spite of so many communities around the globe taking the environmental cost of convenience in a shopping bag seriously, it's still all too messy to find a retailer that's keen to handle over a single-use sack of polyethylene with your purchase. Once used, there's an all too likely chance the bag will find its way into a landfill rather than a recycling plant, or worse still, exposed somewhere out in the landscape where eventually it flutters away into waterways or the ocean to join the astonishing 640,000 tons of plastic dumped by commercial fishing every year. Kindly support my Patreon account since YouTube has again demonetized my YouTube channel. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box below. The ultimate fate of this plastic debris is anybody's guess. The whole bunch ends up in the guts of wildlife, birds and whales, for example. Eventually it breaks down into increasingly tiny microscopic chunks, but many of the details on its distribution and fragmentation remain unclear. Studies over the years hinted at the possibility of more sinister transformations, with research finding that sunlight can chemically transform plastic and additives into new polymers, as well as smaller chemical units that dissolve more easily and are made airborne. Individual discoveries are one thing. What is not known until now is the sheer diversity of chemical products a plastic item can produce as it sits baking in the sunlight. Researchers collected together a sample of consumer polyethylene bags from commercial enterprises such as Target and Walmart's. Researchers also included a used bag from CVS in a municipality with plastic bag ban, an additive-free, low-density film bag made by Goodfellow served as a control. The bags were characterized in terms of organic and metal content and spectral qualities. Researchers placed swatches from the bags into sterilized beakers filled with ionized solution to simulate immersion in seawater. Half of the beakers went in a dark drawer for 6 days, and the rest were left in a temperature-controlled chamber for 5 days, bathed in a constant stream of radiation that mimicked the effects of sunlight. Samples left in the dark were found to have released a tiny amount of dissolved organic compounds into the salty solution. Those left in the light were swimming in new chemicals. The used CVS bags presented the greatest difference in concentrations between the darkened container and the one exposed to sunlight, a measure that only went up the longer it was left in the light. Pulling apart this plastic soup into the list of its constituent molecules revealed tens of thousands of dissolved organic compounds, all produced on a timescale equivalent just weeks to floating about in the ocean under the glare of the sun. The entire process is at least 10 times more complex than chemists previously understood, leaving plenty of room for toxic materials we never even considered to be an issue. Chemist Colin Ward says, "It's astonishing to think that sunlight can break down plastic which is essentially one compound that typically has some additives mixed into tens of thousands of compounds that dissolve in water. He says we need to be thinking not only about the fate and impacts of the initial plastic that gets leaked into the environment, but also about the transformation of those materials. Precisely what those compounds do in the environment or the tissues of the organisms living in it is now the big question. In low concentrations, there might be relatively little to worry about, but as that plastic waste piles up in an ever-increasing environmental catastrophe, those concentrations could climb to levels we wished we'd paid attention to sooner, obviously. He says if the goal is to understand the fate and impacts of these materials, we need to study plastics that are representative of those that are actually leaked into the environment, as well as study the weathering process acting on them, says Ward. This was published in Environmental Science and Technology, and it's on Science Alert by Mike McRae. Please leave your comments, and thank you for your support.